winding around this in little centripetal spirals, and each one of them makes little, well, on a larger scale it's doing this. It makes a little particle right there because of the discharge of the earth that meets it. It cannot produce a particle until it is produced as a wave that has been created because the rays that arrive at the earth come in waves. In an equipotential layer like this, if they have time to take the course, but when there's an unbalanced condition, they take shortcuts across potential, and that's what sun rays always do because they're higher potential than the potential of the earth surrounding it. But as it does, it makes these little bodies here that come in here. And those bodies charge the earth. It's the bodies that are charging the earth constantly by arriving here. It's bodies that you may call atoms, no matter what you may call them. And those charging bodies come from all of the space octaves as well as from the great octaves. Space is filled with other potentials, and the inner gases of those potentials, the lower inner gases of those potentials are the rays that accumulate these little particles that we call cosmic rays as against the rays of the gases of a high potential like the sun. If this planet got violently or had some strain or tension that seemed to try to put it violently out of balance, there would be such a tremendous influx of particles onto this earth from the sun and from other bodies in changing it. It would be just as though it were being pulled and pushed by every one of them to keep itself in place. Because God does not allow unbalance in His organization. And so the particles that are wound up, as I say, there is no motion in this direction. From point of gravity to point of gravity, there is no motion. North-south, between polarization anywhere, between centers of gravity. The motion is around that always, spirally. As I explained to you yesterday, as a tree grows in its motion around it, if you go and look at the tree, you'll find that find spiral lines of its growth just like this, instead of the great spiral of its beginning. You find that it's registered itself here in spiral lines. Nothing can go away from the earth in a direct radial line between gravity and gravity. It can only spirally swept around it anyway, and so that the heat rays coming from the earth, from the sun to the earth, or from any other planet to the earth, in interchanging, have got to take their spiral journeys around gravity, between centers of gravity. And taking those spiral journeys around, they wind up with little particles of matter. And the cosmic rays are the particles of matter that are wound up from the space octave, and other particles of matter are the atoms, are wound up from the octaves we're familiar with. That is all I can go into it today, but it's worth 2 or 3 lectures, really. You have frequently mentioned about the time when our Earth gets out to where Neptune is. Does that mean that the orbit of our Earth around the Sun is gradually increasing? That is, that we are not traveling around the Sun in a circle, but in an ever-increasing spiral. Are we a few miles further away from the Sun each year, according to this? I better answer this as I go. Our Earth is not traveling in circles around the Sun, is traveling in ellipses around the Sun. because the got to better like that. This is the sun's equator, where the planets are born upon that equator. And they would all be born upon that equator if the sun is a true circle, but it's not quite, a true sphere, not quite a true sphere. So the planets that are born come off of that equator like this, so that Mercury is here and Venus is here and Earth is out here. 23 degrees removed from this direction. Any planet born here would have a truly, on the equator, would have an absolutely true circular orbit. But a planet born here would not have a true circular orbit because it is in the position of this, for instance, gravity, like a top that is wobbly. Here's the sun, here's the earth. If the planet were on the equator of the sun, it would be a circle, which would be a section of a cone, but it's here. And this kind of a section of a cone is an ellipse. One side, one end of the ellipse nearer to the center of gravity than the other, so that we have two closely here. So this goes around the sun as any point on the spinning top that is out of true will go around in an ellipse. But it's spreading farther and farther away as it goes and losing and losing direction in this way, because the destination of that gradually, the destination of this earth is here. We will plunge directly headfirst in the sun as we dissipate in rings, and then moons, other satellites, and finally comets, and all just shorten up this journey and lengthen this one. Shorten this up into greater sections until this is the kind of a section you get. This is a section of a comet. There's the sun. And this is the orbit of the comet. The aphelion, the perihelion is here. The aphelion is there. Hundreds of years may take place in this part of the journey. And as it gets near the sun, in a higher potential, a streamer of light will stream away from that, away from the sun, being pushed out. And that will travel very fast around there and come out into space. But each time it comes out into space, it is nearer the sun and farther away from it until the orbit is more like this. And finally, when the orbit gets to this point, it goes directly head first right into the sun and disappears. The sun will swallow it up as it will swallow up this earth someday. So that spiral is ever increasing in this direction, so that this is really what happens. The spiral which is twisting on itself constantly and trying to make its direction like that. So that if you see the moons of Jupiter, for instance, there are 4 moons in close to the equator, and then they begin to spread out in orbits, moons of Jupiter and of Saturn. And if you look in that's the universal one, there's a drawing that I've made of carrying all of the orbits of the moons of Saturn, or Jupiter, with their planes between them, all carried out in such a way until the farthest one outside is almost 90 degrees from Jupiter. And that will split up and lose its ability to circle around its primary when it gets to 90 degrees. And it will leave the solar system as comets always do, and the sun will become its primary. Our moon will do likewise. Our moon is circling around our Earth. But when it gets up to the point where it's 90 degrees from the equator, it will no longer be in the solar system orbit. It will then allow its allegiance to the sun and will circle around the sun in an ever-increasing, narrowing ellipse, just as the comets do, until itself becomes a comet and disappears, so that one half of its journey is hundreds of years, can be hundreds of years, and the other half of the journey 100 days. And the ever-increasing spiral, these feet, so we're a few miles farther away. We're not a few miles farther away from the sun each year. It's a strange thing, but the duration of time of a planet and sun is so vast that in several centuries, well, say in a century, a full century, there may be a difference of 1 second of time in duration of our day. And that 1 second of time in the duration of our day shows that we have a vast number of years to live and propagate human life before we get out to where Mars is, because Mars is 60 million miles farther away. Is this 90 to 120 million? Well, it's a long way out anyway. So, we're not a few miles farther away, we're just a little bit. Will this increasing distance from the sun affect the speed of the turns of our Earth on its axis, and thereby shorten or lengthen our days? If so, would we be aware of this shortening or lengthening, or would all our time-measuring devices accommodate themselves to the change because of the variations in gravity? We would not be aware of it because the time element is so great, so vast, that in generations will not note the slightest difference, so there's no need of making a change of calculations. The Earth is moving on its axis in such a way that it is wobbling this way, like the top, to such an extent that the axis that points toward the North Star right now will, in 3,000 or 4,000 years, point to another star, and to another star, and to another star. We'll always have a change in our North Star, so that at the time they built the pyramids, for instance, they built a passage pointing to the North Star. It doesn't point to that North Star anymore. That North Star is over here, where it's pointing now, it's over here. And that change of that, because of that wobbling that we call the precession of the equinox, that slow wobbling is only 1 turn in 27,000 years. Now, just that 1 turn in 27,000 years is a whole lot of time. And during that 27,000 years, this Earth may not have moved to a point where our days are changed by more than 1 minute. Or probably not that. So we have a long, long time to think things over.